What's up guys? In today's video, we're going to talk about vector and scalar projections. So before we dive into any of the examples, we need to understand what vector and scalar projections are and how they're different to each other. So we'll start with scalar projection. So scalar projection. What is a scalar quantity? A scalar quantity gives us only a magnitude. So to understand scalar projection, let's look at this diagram over here. It says for scalar projection, we only worry about the magnitude of a vector projecting onto another vector. So in this case, we have vector B over here. We need to worry about how much, so the magnitude of vector B projecting onto vector A. So the formula for scalar projection then becomes magnitude of vector A multiplied by cos theta. To further simplify this, or to make this more sense, we can rewrite this as A dot B all upon the magnitude of B. That is the textbook definition or textbook formula for vector projection, but A dot B is also written as magnitude of A multiplied by magnitude of B multiplied by cos theta. This and this cancel, which then leaves me with magnitude of A cos theta. So that is basically just scalar projection. We don't worry about what direction the vector is being projected at. It's only the magnitude is what we worry about. Vector projection, on the other hand, we need to worry about the direction of the vector that is being projected from. So same process, it's still magnitude of A cos theta, but this time we multiply this by the unit vector of A. So unit vector of this. That is the difference between scalar and vector projections. Now let's get into the two examples for this. Let's look at this first example here. We've been given formulas that will help us solve these questions over here. So we've got the vector projection formula, we've got the scalar projection formula, and we've got the projection when it's perpendicular over here. So example 1, known vectors x equals to 4i plus 5j plus k, and y, vector y, is negative 2i plus 2j plus 3k. A, find scalar projection A onto B, and B says vector projection, so find vector projection both A onto B and A perpendicular to B. So let's start with A over here. Draw a quick line, get some space. A, scalar projection A onto B. So come back to this formula over here. So first thing we'll do is take the dot product of this. So let me rewrite this as x dot y all upon magnitude of y over here. Take the dot product of this, so 4 times negative 2 is negative 8 minus 8 plus 5 times 2 is 10 plus 3 times 1, which will be 3 in this case, plus 3. We then get negative 8 plus 10 is 2 plus 3 is 5. 5, that's the dot product at the top, all upon the magnitude of y. Magnitude of y is 2 squared is 4 plus 4, which is 8, plus 3 squared, which is 9. 8 plus 9 is root 17. 17. So we can further simplify this as 5 root 17 all upon 17. So that is A. That is the scalar projection magnitude of A onto B. Now let's do B over here. Extra space. Vector projection A onto B. We're going to use this formula So we already know what the dot product is. This thing over here, b dot b, equals to the magnitude of b all squared. So root 17 multiplied by root 17 will just give me 17 in this case. So let's rewrite this as a dot b, 5 on 17 brackets vector y minus 2i plus 2j plus 3k. Just to fully simplify this, for those that have been confused, we already found out what x dot y was earlier, looking at this formula over here. So x dot y gives us 5 upon b dot b, which is also as magnitude of b all squared. Magnitude of b we found was root 17. Root 17 all squared is going to be 5 on 17 multiplied by vector b over here, which is this. It's 2i minus 2i plus 2j plus 3k. Next part we have is a perpendicular to b. A perpendicular to b is going to be this formula here. So we have vector x minus this over here, this vector. 5 on 17, we have minus 2i plus 2j plus 3k. Vector x is 4i plus 5j plus k minus 5 on 17 minus 2i plus 2j plus 3k. Further simplify this. We can go multiply both sides by the top and bottom by 17. Upon 17, we get 17 brackets 4i plus 5j plus k minus 5 minus 2i plus 2j plus 3k all upon 17. So we'll leave it as that. That is the final answer for vector A perpendicular to B. So that is how you do example 1. Now we'll go on to the next example.